Okay, this section here talks about something called the rectangular coordinate system. And what we're going to do here, we're going to plot points on a graph, and we're going to state which quadrant each point is in, or on which axis each point lies. So let me explain what we have here. I'm just going to kind of zoom out a little bit so we can see a little bit better. Okay, so in dealing with the coordinate system, we're going to be talking about plotting points. And every point is always going to be in the form x comma y. Now, the first number is going to tell me how to move either left or right, and the second number is going to tell me how to move either up or down, okay? And we have something here called the coordinate system, okay? And so basically what it is, it's a big plane, so it's like a rectangle or a square, and we've cut it up into 4 pieces. And so we have, because it's 4 pieces, we have these things called quadrants. So this is quadrant 1, this is quadrant 2, this one over here is quadrant 3, and this last one down here on the bottom is quadrant 4. And then we have what we call our x-axis here and our y-axis here. So what we're going to do is we're going to plot these points. So if you notice, the first point is the point 2 comma 3. So remember we said the first number is going to tell me how to move either left or right. Second number is going to tell me how to move either up or down. I'm always going to start right here in the middle. I'm just going to put a little dot. I'm not going to always put a little dot, but I just want to let you know where it is I'm starting, okay? So I'm going to start right there, and the first number is positive 2. So I'm going to move 2 spaces to the right. The second number is a positive 3, so from there I'm going to move 3 spaces up, and this right here is going to be my point for A, okay? So let's do the same thing for the point B. Remember, we're always going to start in the middle. So it's negative 3 and 5. So since it's a negative 3, I'm going to go 3 to the left, and then I'm going to come up 5, and here's my point B. Let's do for C. C is the point 2 and negative 4. So I'm going to move to the right 2, and then down to 4. There's my point C. And then our point D is the point negative 3 and negative 1. So I'm going to move 3 to the left and then down 1. There's my point D. E is the point 0, 2. So since the first number is 0, I'm not going to move left or right. I'm just going to stay right there. Since the second number is a 2, I'm going to move up to 2, right? Because remember, the first number, always left or right. Second number, always up and down. Okay. Then finally, the point F is negative 4, 0. So I'm going to move to the left 4, and then I'm going to stay right there. Oops. And so, oops, trying to get my eraser. Here we go. So this is the point in negative 4 and 0. Okay, now the directions say, so we're going to plotting our points. We're going to state which quadrant each point is on, or on which axis. So we look here. This is going to be in quadrant 1. Okay. B is going to be in quadrant 2. I'm just going to put the Roman numeral 2. C is in quadrant 4. D is in quadrant 3. E is on the y-axis. And F is on the x-axis, okay? So again, all we're doing is plotting points. So let's go into the next problem here. So this problem, similar to the one we did before, but now we're kind of going backwards. The points are here. We want to find the coordinates of those points, okay? So let's take a look at the point A. If it's right in the middle, it's 0, 0. Point B, we moved to the right. It looks like 3.5. And then we didn't go up or down, so that's going to be a 0 for the second one. For C, we went to the right 3, and then we went up 2. So remember, it's always the left and right, and then up and down. That's the order I need to write them in, okay? So D is to the left 1, so a negative 1, and then up to 3. E is left 2, so negative 2, and down negative 2. And then F, I'm going to write it over here. F looks like we didn't move to the left or the right, so it's a 0, and then we move down to a negative 1. And then finally G looks like we moved to the right 2, and then down 1, so it's a negative 1. Okay, so again, we're just plotting our points or finding the coordinates, okay? So guys, just to give you a little heads up, when you find something like point B right here, notice it's right in the middle, so it's 3.5, okay? don't get too nervous about, oh, is it 3.4? Is it 3.8? It's going to be, 3.5, stuff like that, okay? All right. So the next thing we're going to talk about is what we call solutions of linear equations. So in solutions of linear equations, remember we said every point is in the form x and y. So here's the first equation we have. And we're going to do this in pieces. So this is going to be kind of like my first problem. So my part A says there's a blank and then a -2. Since every point is in the form x and y, this is telling me that I don't know what the letter x is, but we do know that the letter y is the number -2. So what we're going to do is we're going to come to this equation here, and everywhere we have the letter y, we're going to plug in the number -2, okay? So we're going to write x minus 4 times -2 is equal to 4, and now we're just going to solve for x. So let's see. A negative and a negative is a positive, so that's a plus 8 equals 4. We're going to minus 8 on both sides. And 4 minus 8 is a -4, right? So all that means is right here, y'all, I'm just going to put the number -4. Okay. Now, we're going to do this a second time. This is kind of like my part B. So my part B, we have the point 4 comma blank. So that means that I know that the letter x is 4, but I don't know what y is. So I'm going to write out my equation, x minus 4y equals 4, and everywhere we have the letter x, we're going to plug in the number 4. Okay. Remember, we're trying to solve for y from here, so I'm going to go ahead and subtract my 4 on each side. This is going to leave me with a -4y. 4 minus 4 is 0. And then we can just divide both sides by the number in front of the y, which is a -4. Now 0 divided by -4 is still going to give me 0, right? So then right here, I'm just going to put the number 0. And so really what I'm doing with these problems, y'all, is I always call these problems here plug and chug. Because what I'm doing is I'm figuring out what letter do I know. I'm going to plug that in. I'm going to chug along until I get to my answer, okay? So I'm going to kind of keep moving along here. We're going to do the same thing here. Don't get nervous if you see a fraction. It's going to be fine, okay? So remember, every point is always in the form x and y, right? So again, I'm going to do this like in two pieces. My part A, this is a -8, and then we have a blank, which tells me that I know that x is -8, but I don't know the value of y. Okay, so we're going to find that. So we're going to write out an equation, y equals 1 over 4x minus 3. And now what we're going to do is everywhere we have the letter x, we're going to plug in the number -8. Now, I want you to notice, since I have a fraction in front of that, in front of my parentheses, I'm going to write -8 as a fraction, just by writing it as -8 over 1, okay? Now, remember how we multiply fractions? We just go straight across. So that's a -8 over a positive 4 minus 3. Okay. So let's see, -8 divided by 4 is a -2. And so guys, if you all struggle with, how do I combine numbers when they have different signs? Think about it this way. Think about negative as how much money you owe and positive is how much money I have, okay? So when I'm looking at this problem here, this means I owe you $2. Since there's another minus here, I'm borrowing another 3. So now I'm going to owe you $5, right? So then right here, I'm just going to put in the number -5. All right? And then I'm going to do this problem all over again. I'm going to do my part B, which is this piece right here. So this is a blank and a 1, which again tells me I don't know the value of x, but we do know that the value of y is equal to 1. So when I look at my equation, which is y equals 1 over 4x minus 3, wherever we have a y, we're going to put the number 1. Okay. So I'm going to go ahead and add 3 to both sides. And this is going to give me a 4 equals a 1 over 4x. Now, the way I get rid of that 1 over 4 is I'm going to multiply by the reciprocal of the number in front of my x. So the reciprocal says, let's take a look at this number, and let's multiply by when we flip it. Okay? So the reason why I'm going to do that is I'm going to work with this side first. So 4 times 1 is 4. 1 times 4 is also 4. Here's an x. 4 divided by 4 is 1 or a 1x, right? Now I can do the same thing here. Think about this 4 is 4 over 1. Multiply straight across, right? So 4 times 4 is 16 over 1. And 16 divided by 1 is still 16. So then right here, y'all, I'm just going to plug in the number 16. Okay? Alrighty. So let's take a look at this next problem. I'm going to go about it exactly the same way, okay? So I want you to think about it like this. Think about this one now has 3 parts, okay? There's a part A, there's a part B, there's a part C. So we're just going to do this 3 times, right? So for part A, we know that x is 0, but we don't know what y is. So when we write out our equation, x equals negative y plus 2, now we're going to plug in a 0 for x. So 0 equals negative y plus 2. Remember, I'm trying to solve for the letter y. So I'm going to go ahead and subtract 2 on both sides. This is going to give me a negative 2 equals, I can think about this y, y'all, in case it helps, as a negative 1 times y. Now, what we want to do is we want to get rid of the number in front of the y, and since it's being multiplied, we're going to do the opposite. We're going to divide, okay? So a negative 2 divided by a negative 1 is just a positive 2. So right here, I'm going to come back to my original problem. Let's see. Here we go. And the number we came up with for y was a 2. So I'm just going to put a 2 right there, okay? All right, we're going to do this a second time. We're going to do part B. So part B is telling me I don't know what the letter x is, but I do know that the letter y is 0, right? So remember, here's my equation. X equals negative y plus 2. Remember, I can think about this as a negative 1 times y, if it helps, okay? Now, the reason why I want you to think about that is, remember, what number are we plugging in for y? We're plugging in 0. So negative 1 times 0, it's still 0, right? And 0 plus 2 is just 2, so I'm going to put a 2 right there. Okay. We're almost done. We've got a third part now. So in the third part, we do know that x is equal to a minus 3, but we don't know the value of y. So again, I'm going to write down my equation. X equals, and again, I'm going to think about it as a negative 1y plus 2, and we're plugging in the negative 3 right over here. Oops. Sorry about that, Neil. Come on. Here we go. Okay, so now, since I'm trying to solve for y, I'm going to go ahead and subtract 2 on both sides. So this is a negative 5 equals a negative 1y. And when I divide both sides by a minus 1, negative 5 divided by negative 1 is a positive 5, right? So I'm going to come back over here, and I'm going to put a positive 5. So again, really what I was trying to emphasize or illustrate by this problem, guys, is it really wasn't any different from the other one, other than they gave me the values in a table. And so I'm just doing this process like 3 times, right? And I just got to remember, which are the values that they're giving me. Okay. So look, we got another one, almost the same, right? Pretty much the same type problem. We're going to call this part A, part B, and part C. So once again, in part A, we do know that x is 0. We don't know the value of y. And our equation is x plus 3y is equal to 6. And so we're going to plug in x equals 0, right? Oops. Okay. So we're going to put 0 plus 3y equals 6. So 0 plus 3y is still 3y equals 6. So we can divide both sides by 3. And we come up with y equals 2. So we're just going to put a 2 right there. Okay. And then we'll do this a second time, part B. And in part B, we do know that now y is 0, and we don't know the value of x. So x plus 3y equals 6. So x plus 3 times 0 is equal to 6. And 3 times 0 is still 0. And x plus 0 is just x. So now x is equal to 6. So I'm going to put a 6 right here. Okay. And then I'm going to do this a last time. And in this last one, we don't know the value of x, but we do know that y is equal to 1. So when we write our equation, everywhere we have the letter y, we're going to plug in the number 1, right? So 3 times 1, that's just 3. And if I'm trying to solve for x, I'm going to go ahead and subtract 3 on both sides. And we're coming up with x equals 3. And so I'm just going to put a 3 right there. Okay. So again, I mentioned this earlier, but I'm hoping that you all can see that these problems here are very much plug and chug, okay? And so you're just taking the numbers, you're plugging in, and you're just kind of chugging along trying to find the other one, right? So we got one more like this. Let's do this, and then I'm going to show you what we're going to do once we get those numbers. And you can see we have a graph. We're going to use that graph, okay? All right, so again, one more time. This is my A, my B, and my C, right? Okay, so let's do this in pieces. So for part A, we know that x is 0. We don't know what y is. So our equation is 1/3 x plus 2. And we're going to plug in the number 0 for x. So 1/3 times 0 is still 0. And 0 plus 2, well, that's just going to stay at 2, right? Okay. And in part B, we know that x is a -3, but we don't know what y is. So when we look at our equation here, now what we're going to do is everywhere we have an x, we're going to plug in the number -3. So I'm going to write that as a -3 over 1, okay, plus 2, just because we have a fraction. Okay. Remember how we multiply fractions? We just go straight across. So that's a -3 over 3 plus 2. Okay. And so -3 divided by +3 is -1. And -1 plus 2, so remember, if I owe you $1 but I have 2, I'm still left with 1, right? Okay, and then we have one last part. So let's do it right here. So in part C, we don't know what x is. Oops. We don't know what x is, but we do know that the value of y is 0. Okay, so when I look at my equation, which is y equals 1/3 x plus 2, I'm going to put a 0 right here, equals a 1/3 x plus 2. Okay, I'm just going to kind of scooch this up. So remember, first step is let me subtract 2 on both sides. So this is going to give me a -2 equals a 1/3 x. I'm going to write that over here again. -2 equals a 1/3 x. Now we did something like this earlier. When I have a fraction in front, I'm going to multiply it by the reciprocal. The reciprocal just means let's flip it. Okay, multiplying, right? So I'm going to think of this over 1 as well. So the reason why I want to do that, notice here, 3 times 1 is 3. 1 times 3 is also 3 with an x. When I multiply these, that's a -6 over 1. And then -6 divided by 1 is just -6. 3 divided by 3 is a 1, so I have a 1x. So my x is a -6, right? Okay. Now, the reason why we're going to do that is now we're going to go ahead and plot our points, okay? So let's worry about plotting our points. So this one here, remember, the first number tells me how to move left or right. The second number tells me how to move up and down. So we're not going to move left or right, but we are going to go up to 2. The second one here, -3 and 1, says go to the left 3 and then up 1. And then this one that we just found right now, -60, says go to the left 6. Well, if this is 5, this one has to be 6, and we're not going up. And what we've really done here, y'all, is we have graphed a line, okay? We have graphed a line. And so that's what we're trying to do, right? We're going to be looking a little bit about some linear stuff, linear relationships, okay? All right. So one of the things we're going to talk about in terms of lines is something called the slope of a line, okay? And so the slope of a line is passing through these points right here. And we have a point x1 and y1 and a point x2 and y2. Now remember, y'all, I told you our points are always going to be like this, x and y. These little ones and these little twos don't necessarily mean I'm going to write the number 1 or write the number 2. It's just that this is my first point, like my point 1, and that's my second point, point 2. So the x1 and y1 refers to the coordinates of the first point, and the x2, y2 just refers to the coordinates of the second point. So we have a formula right here on how we find the slope, okay? So we're going to use this formula to talk about or to actually do these problems here. So the first one says find the slope of the line through the point -2, 3 and the point 4, 1, and then graph the line. Okay, so think about it this way. This is going to be my, since that's my first point, oh, come on, pen, here we go. This is going to be my x1 and my y1, and this is going to be my x2 and my y2. So the first thing I'm going to do, y'all, I do this every time because it helps me remember the formula, and then it helps me realize what numbers I need to plug in where, okay? Because this problem is also going to be kind of plug and chug. So I want you to notice something. It says y2. So here's y2, -1. Then there's a minus sign. I'm going to write a minus sign. And it says y1. So y1 is right here. It's the number 3. And then it says x2. Okay, here's my number x2, 4. And then again, there's a minus sign, so I'm going to write it. X1. So here's my x1. I'm going to write the number -2 because that's the number that I have right there. Okay. So now we're going to go ahead and finish this off. Remember, -1 minus 3, I owe you $1. I borrow 3 more. -4. Now, guys, remember, minus and minus make it plus. So 4 plus 2 is 6. And now the only thing I'm going to do, I'm going to go ahead and reduce my fraction. This is a -2/3. Okay. Now, I want to explain what is this, what is all this stuff, what does all this stuff really mean? Okay. So the easiest way to do this is notice the directions also said to graph the line. So remember, let's go ahead and plot this point, -2 and 3. So -2 and 3 means I'm going to go to the left 2 and I'm going to come up to 3. So there's that point right there. And then the point 4 and -1 means I'm going to go to the right 4 and down 1. So that's that point right there. And then I'm going to do my best to try to draw this as straight as I can. Okay. All right. So here was our slope, right? And then we just drew our line. So often we call the slope the rise over the run, okay? So what I want to do here for you all is I'm going to go to the point that we started off with, this point right all the way up here. And since we're talking about the rise of the run, I want you to notice the top number on my slope here. It's a -2. So I'm going to actually fall down 2 spaces. What I mean by that is going to go like this, 1, 2. Since the bottom number is a +3, 1, 2, 3. Look, we found another point on our line. And we can keep playing that game. 1, 2, 1, 2, 3. There's another point on our line. And we can continue to do this. 1, 2, 1, 2, 3. Look, there's another point on the line, right? So that's what the slope of the line tells me. The slope of the line tells me how do I move from one point to another, okay? And that's how we do it. Now, another thing I want to point out here, y'all, is the way I read a line is just like the way I read a sentence. We read a sentence from the left to the right, okay? So when we're looking at this line right here, and I'm going to make it a little bit thicker so you can see what I'm referring to. When we're doing this line here, I want you to notice as I'm going from the left to the right, that line is going downward, right? That line is going down, and it's not because there's a down arrow and up arrow. It's because as I go from the left to the right, this line is falling, right? Look at our slope. Our slope happened to be negative. So if my slope is negative, my line should go down. Okay? Let's do the same thing. Here's another problem. Exactly the same way, okay? So the first thing I'm going to do is I'm going to write the formula that we had on the previous page. Okay, that's my formula, right? X1. And because this is my first point, I'm going to call that one X1 and Y1. And because this is my second point, I'm going to call it X2 and Y2. Okay. Now, we're going to do a little plug and chug. Look, Y2. Here's my number Y2, 5. There's always a minus, so I'm always going to write a minus. Y1 is the number 1. Okay. And then X2. Here's X2, 3. There's always a minus, so you got to write it down. X1. In this case, it is a negative 2. Okay. So 5 minus 1 is 4. Minus and minus become plus. This is 5. Okay. Now remember who we said we call the slope of the line. We call it the rise over the run. So like I did earlier, y'all, I want to graph these. I want to graph this line. So I'm going to go ahead and plot those points. So negative 2, 1 means go to the left 2 and up to 1. That one right there. 3 and 5 means go to the right 3 and up to 5 right here. And now I'm going to do my best to make this line as straight as I can. Okay. All right. So remember, we're calling our slope the rise over the run, and the top number is 4 and the bottom number is 5. So again, the idea here, y'all, is that from here, I should be able to go 1, 2, 3, 4. 1, 2, 3, 4, 5. And we find a point on a line. And the idea is 1, 2, 3, 4. 1, 2, 3, 4, 5, right? And I'm kind of having to fudge this a little bit because I don't have enough room. But again, that's the idea, right? And this is how I'm moving. Okay, so just like we did in the previous problem, I want you to notice something about my slope. My slope is a positive number. And just like we said, when we read a line, we read it from the left to the right. Just like I read this, I'm going from the left to right. So as I come back and I look at my graph here, right, at my line, I want you to notice this line as I'm moving from the left to the right is going upward, right? And it's going upward and my slope is positive. So what does that tell me? It tells me that a negative slope moves down, and in a positive slope, the line goes up, okay? So now, we're going to do this same idea, and we're going to use the graph to answer some of these questions, okay? So it says, use the graph to find the slope of the line. So the first thing I'm going to do here is I notice, hey, you know what? My line is coming down, so I know it's got to be negative, okay? And all I'm going to do, y'all, is I'm going to count. Remember, we said the slope was the rise over the run. So let me count. How many spaces down do I need to move? 1, 2, 3, 4. So I'm moving down 4. How many spaces to the right? 1, 2, 3. And I'm done. And all I got to know how to do is count, right? Let's do the same thing for the next one here. I'm going to go right here. M. Remember, slope is the rise over the run. Okay. Move my M a little lower. Here we go. Okay, my line is going up, so I know my slope's going to be positive. So I'm going to start counting. 1, 2, 3, 4, 5. Moved up 5 spaces. How many spaces to the right? 1, 2. And I'm done. Okay. Same thing here. I'm going to find the slope. Remember, slope, rise over the run. Okay. All right, let's count. How many spaces up? 1, 2, 3, 4, 5. Okay. How many to the right? 1, 2. There we go. And all I got to do, y'all, is just count. Okay. We got another one. Remember, slope, rise over the run. So the first thing I notice about this line here, y'all, is that the line is coming down, so it's going to be negative. And I'm going to count. How many spaces down? 1, 2, 3, 4, 5, 6, 7. 7. Okay. How many spaces to the right? 1, 2, 3, 4. Boom. And I'm done. All I got to do here is just count, right? Okay. Now, not so much of a trick question, but just something interesting to note. Remember, rise over the run. Remember what we said, if the line is going up, slope's going to be positive number. The line is coming down, slope's going to be a negative number. This line here is not going up, so it can't be positive. And it's not coming down, so it can't be negative. The slope of this line has to be 0. If the line, this is what we call a horizontal line, okay? Horizontal. Okay? If I got a horizontal line, the slope is going to be 0, okay? And the reason being, if we were to say, okay, how many spaces do I got to move up to get to this one? Well, I don't move up, so I move up 0 spaces, okay? So anytime we got a horizontal line, y'all, slope's going to be 0. Now, another interesting note, this here is what we call a vertical line, okay? Anytime we have a vertical line, we say the slope is undefined, right? Is that line going up? Yes. So it's positive. Is that line going down? Yes. So it's negative. So it's very difficult to determine, is it going up, is it going down? So we say it's undefined, okay? Vertical lines, slope is undefined. Okay, so slopes, guys, are basically rates of change. And so what I have right here is how would we find what we call the rate, okay? So let's read through the problem, and it says, the following graph shows data from a technical assistance call center. It says, at what rate are calls being handled? Okay, so let's think about this. I'm going to look at my picture here, right? So I know at 10 a.m., at 10 a.m., we had 30 calls. And then here at 1 o'clock in the afternoon, we've had 90 calls. So since we're trying to figure out at what rate are calls being handled, okay, so we want to know calls, because this is the number of calls, and this is the time in hours, calls per hour, okay? So one way we can do this is we can say, well, look, if, let me clean up some of this mess here. And I'm going to look at these two numbers. So if we knew at 1 o'clock we had 90 calls, and at 10 a.m. we had 30 calls, how many calls occurred in that period? So we would say, well, let's take 90 minus 30. And how many hours have elapsed here? So that's 1 hour, that's 2 hours, that's 3 hours, right? These are calls, okay? So 90 minus 30, that would be 60 calls that were made in a 3-hour period. So if I divide those numbers out, 3 goes into 60, this is 20 calls every hour, okay? And we were able to find our rate, and this, in essence, y'all, this is how we find the slope of a line. We've just applied it to an actual kind of word problem, okay? So let me scroll to the next one. We're going to go about the same way. And, oops. So let me zoom in. Here we go. Oh, that's not what I wanted to do. There we go. It says, hairdresser. Eve's Custom Cuts has a graph displaying data from a recent day of work. At what rate does Eve work? Okay. So let's take a look at this way. At 2 o'clock in the afternoon, she had already done, this is going to be 7, right? She had already had 7 haircuts. And right here, this is at 4:30, right? Because there are between 4 and 5. She had done 12 haircuts. Okay? So we're going to figure out haircuts per hour. So let's figure out how many haircuts have happened here. So we're going to take 12 minus 7, right? And how much time has passed? If this is 4:30, right? This is 2.5 hours, isn't it? From 2 to 4:30, that's 2.5 hours, okay? So 12 minus 7 is 5 haircuts over 2.5 hours, okay? And then all we need to do, y'all, is just divide those numbers out. So let me get my calculator going, turn it on, here we go, and clear. So 5 divided by 2.5 is 2. So she's doing 2 haircuts every hour. Okay? So I want you to notice, as I'm doing these problems, what's helping me? Looking at the picture, right? Looking at the graph, I'm able to kind of figure out what's going on. Okay? All right, so now we have one dealing with population, and it says the following graph shows the data regarding the population of Lithuania. At what rate is the population changing? Okay, so we're looking at years here. This is 2000, this is 2004. So this is going to be 2001, 2002, 2003, right? So on and so forth. If this is 08, this is 09, this is 2010, this here is 2011. Okay, that's 2011. And this one here is 2001, okay? And let's see if we can figure out, what's the population here? This looks like it's 3.4 million, right? And the population right here is exactly 3 million. So we want to figure out how much did it go down by, right? So I'm going to take 3.4 minus 3, it went, right? And then what's my time difference? Between 2001 and 2011, wouldn't that be about 10 years, right? Okay, so 3.4 minus 3 is going to be a 0.4 over 10, right? I'm just going to get my calculator one more time, y'all. Let me get this going here. So what is 0.4 divided by 10? I'm coming up with a 0.04. So I'm coming up with 0.04. It's going down by this much million population, or millions of people, every year. Now, the one thing I want to emphasize is, look at the line. That line is going downward, right? So what I'm actually going to do here, oops, I'm going to, come on, pen. I'm going to put a negative. This means that it's dropping by 0.4 million people, or 0.04 million people every year, right? Because the population of Lithuania was going down, okay? All right, so we got one more problem here, y'all, and it's talking about the depreciation of an office machine. It says data regarding the value of a particular color copier is represented in the following graph. At what rate is the value changing? Okay, so let's see if we can take a look and figure out what's happening in this problem. So this is the time from the date of purchase in years. So after 2 years, the value of this copier is worth $2,000, and 4 years after we bought it, the value of the copier is worth $1,000, okay? So we're going to find the value in thousands of dollars per year, okay? So let's take a look. From 2,000, it went down to 1,000. So it's gone down by $1,000 in a period of 2 years, right? So again, if I were just to change this to a decimal, right? What I mean by that, look, 1 divided by 2, 0.5. So it's going down by 0.5 thousands of dollars. I can even put a dollar sign right there. Every year, and because it's going down, y'all, I need to put that negative, right? I need to put that negative there. So this is how we find rates, and how rates of lines, or rates, are related to the slope of a line, okay?